Good afternoon. You are welcome to the second week of facilitations. I believe by now you are all familiar with what we are doing based on the course material sent to you. Last week, nobody came for lecture, but I believe you have tried to look at the web page or the course page to check about what we did last week and the video. I think you can find the video under the facilitation session recording. So if you come to this sections of the note, you will see details about the last week lecture. So you just need to copy this link and you paste it in your browser. Then you have access to the recorded versions of last week lecture. So today we move straight to continue from where we stopped last week. So last week is more or less like an introduction, but I tried to start the concept we are to treat today. So actually I gave a breakdown of what and what is expected of us in this course and how we are going to be going about it. So this week now, we are supposed to start fully on functions of complex variable. So which I've started last week. So I will try as much as possible to also recast what I did last week so that those who could not make it last week can actually catch up and follow the class accordingly. So let's go straight to the content. So last week, I try as much as possible to discuss or give a kind of introduction to what we call functions of complex variable. So where I try to explain what complex variables are and how can we use them to solve some basic problem. And also I try as much as possible to discuss some properties of this complex variable, which are of importance to us whenever we are trying to solve problem associated to complex functions. So, like a form of a recast. So last week we defined the complex variable as that can take on values of complex number. An example is z, which can have a and b, and we can write it in form of z is equal to a plus ib. In this case, z is the complex variable where a and b are real numbers. So when you look at complex number critically and you try to analyze it, you will see that there are three terms in this complex function of a thing. We have the z, which is in the left hand side. Then in the right hand side, we have a plus ib. So in this case, a is more or less like the real part of the complex number, where b is the imaginary part, and you can see that it has a letter I behind it. So signifying that that section has to do with what we call the imaginary part of a complex function or a complex number. So we can write it as a is real of z and b is equal to imaginary of z. So this implies that there are two parts of in the equations of this form. So which are the real part and what the imaginary part. I also try to explain properties of complex number. For example, the equality. So if you say that a plus ib is 0, then it's easy for us to say that a is equal to 0 and b is equal to 0, which can be verified. Because once the two main contributing factors to this expression are equal to 0, so automatically the result should be equal to 0. So we also try to look at when you have sets of complex number. So how can you take care of them? What and what are the types of operations you can perform on them? So we discuss about commutative, associative, and distributive. We also look at some of when you are having a complex number and you find the conjugate of it. By the time you add this together, what is going to give you? So we were able to establish that it will give us what a real number. So if you look at these are the laws, the commutative law, the multiplicative law, and the associative law, which has both addition and multiplication. We also have the distributive law. Then I gave this example last week. So I don't know if there is anybody in the house that have tried to check and also try to solve this problem last week so that we look at it together. If you're having an issue, we can actually trash it out and explain and give further explanation on how to solve problems like this. So anybody in the house that has any problem or any questions as regards to these exercises, although there are solutions in the next slide, but it's good that you also try to solve it so that you can master the techniques. So in the exam, you will not be looking. So you know what to do when you are faced with some of these problems and you are asked to solve some of these basic examples. You should be able to do it knowing fully the laws that guides these procedures. So I'm waiting for anybody in the house that has questions or that want to ask one or two things before we move to the next thing. Like I said, these are the solutions of those problems. For the first one, you have this. When z is equals to 2 plus 4i, z2 and z3. By the time you perform the operation on them, you will see that z1 plus z2 is same. The result is same as the result of adding z2 plus what? Z1. The same thing when you multiply them, their result is going to be the same thing. Likewise, when you try to perform a kind of a distributive law on them, you have something like this. So anybody with any questions or any further explanations, and you need one or two clarifications. Okay, in the absence of that, let's move to the next thing that we need to discuss. Theorems on limit of functions. So when you talk of theorems on limit of functions, what are these theorems and how do you use them? So I have listed series of rules or theorems here. The first one, I said limit of c is equals to c when x tends to a. If you look at this now, this is the function c is equals to c. It's more or less like a constant. So automatically, when x tends to a, there is no x in this expression, so the result is still the same thing. So for example, find the limit of 4 when x tends to 2. So there is no place in this expression that you can put x equals to 2. So automatically the limit is still the same thing as 4. That's why we say since 4 is a constant, then the limit of 4 as x approaches 2 is what? 4. So another good example is, another law is limit x is equals to a. So in this case, as x tends to a, so what is x? Once you know the x, then your a is equals to the value of x. So find the limit of x when x tends to 10. So automatically this will be what? Our limit will be what? 10. That is when x tends to 10, the limit is equals to what? 10. This is another law, limit of c of x. This we can write as, because c is a constant, you take it out, then you now have the limit of x. So as x tends to a, whatever you have here, multiplying the constant will give you the limit. Take for example, this is an example, limit of 6 of x, limit of 6x when x tends to 2. Now, 6 here is a constant. You can put it behind it. Then you now have limit of x. So where you see s, you put 2. 2. Now, 2 multiplying by 6 will give you 12. So the limit of x tends to 2 when you have 6 of x. I mean, the limit of 6 of x when x tends to 2 is equals to 12. Any questions on that? If it is not clear, you are free to ask questions. Any questions? Okay, in the absence of no question, then we move to the fourth law or fourth theorems here, or rules, whichever way you call it. So we said that the limiting of f of x plus g of s, we can write this in a form of a split function. So you have the limit of f of x as s tends to a, then plus the limit of g of s as s tends to. So you perform your limit function on each of these separately, then you add them together. So we say find the limit of 5x squared plus 3x as x tends to 2. Now, if you use these rules or this theorem on this, now we can split this into 2 to have 5 limit of x squared as x tends to 2 plus 3 of limit of x as x tends to 2. This is x squared. Where you see x, you put 2. This will give you 4. Multiplying by 5, that will give you 20. Then in this case now, it is just only x. You put 2 there. Then you multiply by 3. Then when you add it, you give you 26. So the limit of 5 of x squared plus 3x when x approaches 2 is equals to 26. Any questions on that? Okay. Now let's look at the next one. Then the limit of f of s multiplying by g of s, we can write it in a separate form as well, that the limit of f of s as s tends to a multiplied by the limit of g of s as s tends to a. Look at this, and this is a very good example. Find the limit of 3x squared dot 68x. So as s tends to 2, you can now have this, the limit of 3x squared as s tends to 2 times the limit of 8x as s tends to 2. Performing the operation separately, you have this as your result, 12 times 16, which give you 192. So the limit of x squared dot 6x as s tends to 2 is 192. Any question? Okay. Now let's look at another theorems or law here. The limit of f of s over g of s. We can also write this in this format, that the limit of f of s of x tends to a, the limit of g of s as s tends to a, which is equivalent to this. A good example is this. If you apply this law or these theorems or this rule on this problem now, you can solve it and have it as equals to 1. The same thing here. This is another law or another theorem or rules. The limit of the square root of f of x, that is n now, the n root of f of s, we can write it in this format. Just put the square root, the n roots all over the limit of the function when the s tends to a. Once you perform that, you take the root of that, then you have the result. Another good example is this. So the limit, that is another law, rather, the limit of f of s as s tends to a is equals to this. So now let's look at some examples. So find the limit of the following functions. So A, limit 6x as x tends to 2. Limit 4x squared dot 2s as s tends to 3. The limit of 5x over 6 as s tends to 0 to 3. And the limit of 3s squared plus 5x as s tends to 2. These are problems you are expected to solve yourself using some of these rules and some of this law on some of these theorems. By applying them, you should be able to solve some of this problem. And if you have any problem, or if you encounter any difficulties while trying to solve this problem, you can always get across to me via emails. Then we trash things out together. But it's good you lay your hands on it, because they say practice makes perfections. If you don't practice, you may not understand some of the concepts very well. So try as much as possible to solve the problem. So while solving the problem, if you face any challenges, you are free to contact me. I'm here for you to assist you so that you can enjoy the class and as well have a very good grade in the examination. So any problem, any questions so far? Any questions? I'm expecting questions, contributions, or suggestions from the floor. Questions, contributions from the floor. Any questions, contribution, or suggestions from the floor? Okay, fine. In the absence of no questions and no contribution from the floor, I think we have to stop for today. At the end of this class, I'll also upload the video and the recorded versions of these lectures on the course page. I will employ you, advise you to look at it, download it, so that it can help you while you are trying to solve some of the problems. So thank you for coming and have a lovely weekend.